This video is on implicit differentiation. That is, finding dy dx when the variables cannot be separated. How can the derivative dy dx be found when y of x cannot be separated from the rest of an equation? This requires the same technique as for finding the derivative of any composite function, the chain rule. This is best handled by illustrating the technique using an example. An example that is not very complex is find dy dx, where e to the xy equals xy cubed. No matter what you do, you cannot get y by itself, so you cannot find forcibly dy dx with an expression containing only x on the other side, which would normally happen. So here we're going to take the derivative with respect to x of each side of the expression. The derivative of e to the xy then equals the derivative of xy cubed. So we will take the derivative with respect to x of both sides of the equation. We're going to be using the product rule here. The derivative of e to the xy is the derivative of e to something is e to the something times the derivative of the something. So the derivative of xy, the first function, x, times the derivative of y with respect to x, plus the second function, y, times the derivative of x, which is 1. That's equal to, here we have a product rule. So we have the first function, x, times the derivative of y cubed, which is 3x squared, dy dx, because we have to use the chain rule here, plus y cubed times the derivative of x, which is 1. So we have now to remove the parentheses so that we can collect the dy dx terms, which is our goal. So if we take the parentheses out and multiply through by e to the xy, we get x e to the xy dy dx plus y times e to the xy equals 3x squared dy dx plus y cubed. Now we'll collect the terms that contain dy dx, the derivative of y, on one side of the equation and the remaining terms on the other. So we'll start here, x e to the xy dy dx minus 3xy squared dy dx equals y cubed term minus, because I'm moving to the other side, y e to the xy. Then we will factor out dy dx on the left side of the equation. So we have dy dx times x e to the xy minus 3xy squared. We haven't touched the right-hand side, so it will remain the same. Finally, we will divide by whatever is multiplying the dy dx, which is everything in the parentheses. So we have dy dx equals y cubed minus y e to the xy divided by x e to the xy minus 3xy squared. Yes, y is still part of the expression for dx dy, but its derivative in terms of the variables x and y has in fact been found. This is what we call implicit differentiation. Please consider subscribing to our channel. We will be adding more videos as time goes on. They will be in math and in physics and various topics as they're ready. Thank you.